Okay, daily task 2. Now this task involves you remembering or recalling the definition for an element, a compound and a mixture. And in order to be able to give an example for each, which you're also asked, you need to understand what each of these definitions mean. You can pause the video and think about what you understand of element, compound and mixture before starting it again. Okay, the element then. An element are any of those elements that you find on the periodic table. Now this is my periodic table for when I was in school, and any of the elements you choose on here will fall under our definition of an element. Now that doesn't help us explain what an element actually is. So an element is something which consists of only one type of atom. There is nothing else involved at all, just any one type. So again, on our periodic table, let's say lithium is an element. You put nothing else with lithium, it's an element. And it doesn't matter if there is one atom of lithium or a billion atoms of lithium. As long as they are all the same, then it is classed as an element. So an element consists of one type of atom. You can also describe it, because it's only one type of atom present, you can also describe it as a pure substance. Okay, so a pure substance made up of only one type of atom. Okay, compound then. Now compound is not an element, but it can use the elements to create it, to be created. Okay, so elements can make up the compound. So compound is, if it's not the same as an element, which is why it's got a different name, it's no longer going to be one type of atom. This is going to be two or more atoms. Okay, so it's two or more different types of atoms, two or more different types of atoms. Now the special thing to remember with this is that they must be chemically bonded. So it's two or more different types of atoms chemically bonded together. Chemically bonded together. Good. Okay, and a mixture. Now you've all used mixtures in your everyday life. When you eat your food every day, you're mixing different things together. If you've ever had a fruit salad, that's a mixture of different types of fruit. So how does this help us understand what a mixture is? Well, we know it's not an element, not one type of atom, but if it's not one type of atom, it must be more than one type of atom. But it's not two or more different atoms chemically bonded together, because it's not a compound. So a mixture differs by being different substances. Okay, they can be different atoms, it can be different compounds, but this time they are not chemically bonded together. Okay, which means that they are easily separable. A bit like you using your fruit salad and being able to very easily take out all the bits that you don't like. Let's say we take out all the grapes, we don't want the grapes. Easy to separate because they're not chemically bonded together. Okay, so in this case we would write two or more, and because it can be atoms or it can be compounds, I'm going to write two or more substances because that covers everything. Okay, two or more substances that are, in this case, not chemically bonded together, and makes them easy to separate. Okay, good. Now looking at those definitions, can you spot which ones of these examples belong to each of these definitions? Okay, so element first of all, one type of atom, okay, a pure substance, let's also add to that, can be one or many, as long as they are only one type, okay? So can we spot any here that are one type of atom? Now, this is just one type of atom. This, well, there's carbon and oxygen, so it's not one type of atom. Oxygen, but there's two. What does that two mean? That two means that there are two oxygen atoms, okay, that are bonded together. Okay, means there are two of them. If you've got a little subscript number, it means that those two, whatever it's referring to, whatever element that number is adjoined to, means that they are chemically bonded. So we can say that oxygen then is an element, okay, because it's only one type. And remember, it didn't matter if there were one or many. In this case, there are two. As long as it's only one type of atom, it's an element. Au, okay, and we know what Au is? Okay, it's an element called gold. It's only gold there, that's also going to be an element. Nitrogen, again, this subscript number 2, okay, tells us there are two nitrogens and then two of them are chemically bonded together, but there's only one type, so again, it's going to be our element, okay. Hydrogen, again, a subscript 2. Only one type of letter there though, which means it's only one type of atom, which means again it's our element. H2O, well, it's hydrogen with our subscript 2, but it is directly next to an oxygen, so this in itself are two different types of atoms. Okay, we'll look at that a bit later. It doesn't tell us whether it's a what type of atoms are involved in this. Okay, same as salty water, doesn't tell us what type of atoms are involved in that. We'll come back to it in a second. So element, we have chosen our oxygen, we have chosen our nitrogen, our hydrogen, potassium, and our gold. So 1, 2, 3, 4, 5 elements there. Now compound, can we see any species here? Any substances that have two or more different types of atoms? Now, if they're written all together on the same line without any breaks, it means they are chemically bonded together. It's called a molecular formula, and it shows us if they're all bunched together, there's no spaces between them, that they all form bonds with each other. Okay, so carbon and oxygen, yeah, we've got two or more different types of atoms. They're different. They're all joined up, which means we can say they are chemically bonded. So carbon dioxide is a compound. Okay. Next one, we've ruled these out as elements. Next one, H2O. 2 different types of atoms. They're all bunched together, which means that they are chemically bonded together. And this also fits with our description of a compound. So 2 or more different atoms, yes. Chemically bonded, yes. H2O. Good. Now the ones here, you may already be thinking, well, they must be then a mixture. And if I tell you, you already know that salty water consists of water is H2O. Salt, you may or may not know, is NaCl. Okay. So we've got 2 or more substances, okay, so 2 or more different substances. They're not chemically bonded together because they're not, though that's chemically bonded, that is a compound, okay? And because we've got 2 different types of atoms, chemically bonded themselves. H2O, 2 or more different types of atoms, chemically bonded themselves, but this is not chemically bonded to this, which means that it is fit in the description of a mixture. So we can put here salty water. And it's easy to separate. If you've ever swum in the sea and you get out on a hot day and the water evaporates from your skin as you dry it off, sometimes you're left with a salty residue. So it's left behind the salt, which means it was quite easy for that salt to be separated from that water, okay? And air. Air is a mixture. Some examples of what's in that mixture: water, we breathe out water. We breathe out carbon dioxide. We also breathe out some oxygen because we don't use all of it. Okay, there's a bit of nitrogen in there and noble gas, which we haven't covered yet. Okay, so lots of different types of substances. Nitrogen, we've already identified as an element itself. Oxygen, we've already identified as an element itself. H2O, we've identified as a compound. Carbon dioxide, we've also identified as a compound. So we've got 2 or more. Yeah, there's 1, 2, 3, 4 at least in there. Okay, there's a few more I haven't written down, but I don't overcomplicate things. These are elements, these are compounds. So you can see how, by describing the mixture as 2 or more different substances, we cover elements and compounds. Okay. They're all separate to each other. So nitrogen's on its own, oxygen's on its own, carbon dioxide's on its own, water's on its own. They are not chemically bonded to each other. Within each molecule they are, or within each substance they are, but they are not chemically bonded to each other. Okay, so we can say that our air is also a mixture. Good, so that covers all of the questions on daily task 2. Well done.